Hello everyone and welcome to the Clinical Cousins YouTube channel. Today we're going to go over the action potential. An action potential is one depolarization and repolarization. As we know, the resting membrane potential of our cell is around negative 70 millivolts because of our sodium-potassium ATPase, our open potassium channels, and our open chloride channels. We will go over the following parts of an action potential, starting with depolarization. As cations, like sodium, trickle into our cell is made less negative. As soon as the cell hits threshold potential, the activation gates on our sodium channels will open and there will be a huge influx of positive sodium ions into our cell. Our cell becomes so positive, in fact, that our cell overshoots and will have a positive millivoltage. Now, at the very tippy top, another funny thing happens. Our cell's voltage-gated potassium channels open when the cell becomes positive. All of a sudden, positive potassium is leaving our cell. This creates a negative diffusion potential, which makes our cell more negative. This is called repolarization. In fact, our potassium channels will be so open and so much positive potassium will leave our cells that our cell millivoltage will actually dip below what it is at rest. This is called undershoot. During this undershoot, more cation inward current would be needed to reach threshold potential and fire another action potential. This is our cell's way of protecting itself from being overstimulated. Another way that our cell protects itself from being overly stimulated is the refractory period. During our action potential, another action potential cannot be generated because our sodium channel slow inactivation gates are closed when our cell becomes depolarized. Also, lastly, be sure not to confuse this with the EKG. The action potential is for one cell and the EKG is for the electrical activity of the whole heart. Thank you for taking the time to learn with us today, and be sure to tune in to our other videos and subscribe.